Hey guys, this is Mr. Fourth Dimension and you're watching the Geo project. Last time we set up some Ellipse stuff and we said we would spend a little more time to make sure that it was making sense and maybe clean this code up because it's a bit unruly, and I think there's a way we can make it more sensible even as it is now. So I'm going to start by reminding you of what we were doing. So I drew up the ellipse beforehand since it seems I can't actually use my mouse to draw this during the video. So with the ellipse we have these two foci, and we have some. I didn't draw both sides of the triangle. Let me add that second side in. We have these red lines here that are how we define the position of the ellipse. Obviously this isn't correct because I think that if you took the sum of this, that's not correct for the distance to here. These foci actually need to be way farther apart, I think, to make this ellipse correct. But anyway, or this might not even be an ellipse, I don't know. Mathematically, I'm not sure. But anyway, it looks nicer than what I had before. And we were trying to figure out the length of this yellow line, because we know how to calculate the length of the major axis, sort of, the major radius from the center here to the edge, because that just has to be half of the total. If there's some amount that this red always adds up to, half of that will give us the distance from there to there. We discussed that last time. And we were trying to figure out how to get this, and we were using Pythagorean theorem, so I want to make sure that we debug the math first. So I said that this squared plus that squared should equal that squared, right? So then if you jimmy that around, to get this, it's the square root of this minus this while they're squared. So it's the square root of hypotenuse squared minus this squared, right? And I think that's what we have. The square root of hypotenuse squared, right? Because half of that is the hypotenuse, because each of those red lines has to be the same length. So to make them the same length and make their sum r sum, it has to be half of r sum each. So that length is r sum, that's squared, minus the dist squared, which the dist is the distance between the two foci divided by 2, which should give us the correct distance for this, half of that. Because the two sides of the blue line should be equal. It's a little bit rough on the picture. That looks correct. The other thing we should do is do a sanity check to make sure that this is going to be what we think it's going to be. So we put the two foci in the center so that we could get the area of a circle, and we set the radius to 3. Okay, so that's what it is. If this was a circle, this radius of 3 would be correct, but this is actually an ellipse. So what's happened here is, to get the equivalent radius of 3 circle, you have to set this to 6, because this is like it's got to measure that radius twice. So if I put the r sum to 6, that's the same as saying the radius is 3 for a circle. That's probably why it didn't add up last time. So let's put that to the test now, see if that looks like a circle with radius 3. It always takes so long to compile for the first time, I don't know why. Okay, that could be right. So if we take 28.274332, and then we want to divide that by 9, and that is pi. Okay, so that is working. Now we want to clean this up. Up here. Actually, I want to move these down. I wanted to put them near the circle, but I'm changing my mind. I want them to be down here. I'll figure out the right order for the functions to be laid out in some other day. Well, I always want the new thing to be closest to main, I think. Okay, so the thing I'm thinking is I'm dividing dist by 2 here, and I'm dividing r sum by 2 here. And if you do out the math on the Pythagorean theorem, and what I'm talking about is cases where you have let me clear this out. Okay, why is it not clearing out? Solid color. No, what are you doing? What is this thing doing? Can't see any of these shapes that it's drawing right now all of a sudden. Outline, solid color, Okay, so if I do that, alright, that's roughly what I wanted. Not really, but it is what it is. Gives us a nice little panel to do some math in. So, if, what? I don't get this program. Let's skip that. Let's go back to, let's just try to do it this way. So if I have a squared, right, a squared plus b squared equals c squared. Now there's a rule about this that if I have, if I were to compute like the double of a, well actually let's first do the algebra to get this into the form we're actually using. So it's actually, we're using the fact that one of the legs squared is equal to the hypotenuse squared minus another leg squared. That's a nice looking math equation, right? Okay, so we're using this. Now the fun thing is, if I happen to have c doubled and a doubled, then that will just give me a result where b is doubled, because if I double c, that's like, you know, if you have 2 to the 2x, where's my x? There we go. 2x squared is the same as just 4x squared, right, where the square now is only on the x. So if I if I take the 2c and 2a, so I don't divide them by 2 basically, I would get 4c minus 4c squared minus 4a squared, and that equals 4b squared, right? And then if I divide that 4 out, obviously we're right back to the same equation, so it would actually give us the same b. So what I'm saying is we could take b, and we could just do that equals the square root of 4c squared or what I really mean is, I should use the parentheses, 2c squared, right? So if I use double the size of c I actually want to use, and if I use double the size of a that I actually want to use, 2, that's a nice looking 2, right? 2a squared. Then I can divide all of this by 2 at the end, and I'll get the same result, because, you know, after I took the square root of both sides, this 2b would no longer have had the square on the outside of it, so this is divided by 2 and not 4, and these are just the same as computing dis and rsum without dividing by 2. So if I take out this divide by 2 here, and I take out these divided by 2's here, then I can just divide the whole thing by 2 once, and that's a little bit nicer, right? Now the other thing is, if we're going to use the square of the distance, why not just use that right off the bat? Because that will speed things up. So we'll call this dis squared, and then dist squared. So we're able to get a little bit of extra speed out of that by doing the math in a different order, I think. So we can simplify this a bit now, make it easier on the reading. And then, yeah, so let's make sure that everything still adds up. Yeah, that's pretty good. Let's readjust. Now this will change the area. And again, we don't have like an ellipse setup that we, other than the ellipses that are just circles, we don't have ellipses that set up that we just are going to know the areas intuitively for. But let's just make sure that it's reasonable. Yep. So it makes sense that the area gets smaller as the points move farther away. What do you think about that? That's a good question. I think it does make sense because the two long edges basically is if they're moving an equal distance apart. Well, I don't have the picture up anymore. Can I undo all the way to there? No, I can't undo far enough. Oh well. So if you imagine an ellipse where you have 2 points at the center, if you imagine an ellipse, sorry, Emacs was distracting me down there. I don't know if you saw that. So if you have an ellipse with 2 points at the center, and you're measuring, and so it basically turns out to be a circle, right? And then you say, what's the distance from one end of the circle to the other? Well, that whole distance should be 6, right? It's because its radius is going to be 3. And the truth is that the distance between those 2 points won't change, will it? Because if I move the 2 points, if I have my 2 points and I move them one to the right and one to the left, then its total reach from right to left hasn't actually changed. It's now going to put, it's going to take 2 to get from here to the edge on the right, and 4 to get from here to the edge on the right. It'll still add up to 6, and it'll still go all the way out to the point 30, right? So the right-hand side will still be 30, and the left-hand side will still be negative 30. So those sides won't change at all. The only thing that will change is the top and bottom will start to shrink. So it makes sense that the area gets smaller as the foci move away. And the interesting thing is, you can actually make ellipses. You don't know how to see pictures of this, but you can make ellipses where the foci aren't inside the ellipse. So here's an example of the an ellipse where the foci are on the edges of the ellipse, and this basically is just a straight line, and anything less than that is also a straight line, I think. Like anything worse than that is also a straight. Like anything more spread out than that is also a straight line. So it should come out to be 0, unless there's like some weird division by 0 or something that I'm not thinking about. Yeah, that's cool. So, so that's another sanity check that worked out. Alright, one last thing we can try to get started today, and that's a point inside an ellipse. This isn't too hard. To figure out if a point is inside of an ellipse, there's a few ways you might think about doing it, but what was the name of this for the circle? Point in circle? Okay, so it's going to be point in ellipse. Point in ellipse. And for that, I want to use the same form as up here. Point in circle takes a center, a radius, and then the point. So that means I take the foci, the r sum, and then the point in this case. Geo point 2D P. Alright, so the question is P inside the ellipse? Or is it on the edge? Or is it, well, I think we've got that note in a few places, so I'll just only have one copy of it. I want a copy of this function, because it's going to be very similar, and we want to use these same constants, so real 32 is not correct. We want a geo collision type to be the return from this. So first thing we do is we compute the distance. In this case, I don't think we can do squared distances. This time we need to do distances from both foci, because the sum of these will be what's important. And so this is dist 1, this is dist 2. And then what we say is, no, we can't square the radius to check it. What we have to do is say, if r sum, if dist 1 plus dist 2 is greater than r sum, then we're outside of that. If dist 1 plus dist 2 is less than the radius, then we're inside the point, the ellipse. And otherwise, we're somewhere close enough to r sum, oh, that should say r sum. We're somewhere close enough to r sum that it's within the epsilon, so it's going to say, hey, you're colliding with it tangentially, you're on the edge. Okay, so, yeah, let's see if it compiles, because that'll tell me more about if I made mistakes than anything else. There we go. Now let's build a quick test. Geo point in ellipse. Let's move these back together. Now, first point we'll check is the point. Let's see. We know that the point 0, 2 should be inside of this ellipse. Actually, we don't necessarily know that, but I know that because I did math on this particular ellipse at one point yesterday. And then what we want is geo collision type. Collision. Alright, we'll switch on the collision. If it's a geo collision none, we'll do one thing. Alright. Okay, cool. So we want an overlap option and a tangent option. So there's none, overlap, and tangent. So let's see, this should be an overlap. Cool. Let's try a point that's going to be right on the edge, like the one we were discussing, 3.f0, well, 3, 0. Cool. Now one that should be outside is 0, 3, right? Because like we were saying, if this was a perfect circle, 0, 3 would lie on the edge, but we've actually shrunk the top bottom, and so now we're outside. Awesome. So that's pretty good. Maybe we'll test this a little bit more. Try another ellipse. Try an ellipse with 2 foci at the center. But looks like we're on the right way to get that figured out. So I hope this has been interesting. See you guys next time.